Hello and welcome to RATA Skillathon 2026. हर साल में हमारा ये प्रोग्राम होता है जुलाई महीने में और इस साल भी हमारा सेकंड सीजन है। यहाँ पे इस राटा स्किलेथॉन में हम टेक्नीशियंस और प्रोजेक्ट इंजीनियर्स का ट्रेनिंग्स होते हैं। यहाँ पे आज हमारे साथ मिस्टर एसपी सिंह है डाइकिन से, जो एक प्रोफेशनल ट्रेनर है, और मिस्टर सिंह आज हमें R32 रेफ्रिजरेंट्स इसके बारे में बताएंगे और इसको कैसे हैंडल होना है। सिंह साहब, थैंक यू वेरी मच. थैंक यू फॉर जॉइनिंग दिस सेशन. थैंक यू फॉर डूइंग दिस ट्रेनिंग सेशन फॉर अस. थैंक यू वेरी मच.
Thank you very much. So,
okay.
welcome to presentation on refrigerant. So, sir, this program will be in Hindi or English only?
You can decide whichever you are comfortable. हमारे बहुत से व्यूअर्स तो हिंदी में कंफर्टेबल होता है, तो अगर आप हिंदी में कर सकते हैं तो आप हिंदी में कीजिए, नहीं तो आप अंग्रेजी में कर दीजिए, जो भी आप कंफर्टेबल हो, प्रेफर.
Okay. So very warm welcome. So this session is based on refrigerant, and basically we will be talking about HFC refrigerant. And apart from that, we have got other refrigerant also available in the market. And some refrigerants are phased out, and still some are supposed to get phased out. But still, we will be talking more on refrigerant which are available right now, and where our team as an engineer or as a technicians, they are using in the field. So first slide shows that we should take care of earth. It is the only earth available. Right now, you might have heard that alternative, there is no alternative beyond earth. So we have to take care of this earth. So based on this earth, if we can take care of earth, Mother Earth, then everybody survival will be much better, whether it is a human being or whether it is any other creature. Okay. And today we will be talking about the air conditioning, about the refrigerant. And my slide takes you the introduction to refrigerant, environment impact, tools and equipment to be used, and safety precautions while handling the refrigerant. So basically, if we talk about the refrigerant, what is refrigerant? If I'd like to introduce refrigerant, whichever refrigerant you are using. So refrigerant is a working fluid used in the refrigeration cycle system, whether it is a cooling model or whether it is a heat pump. In most of the cases, or in that particular cases, the repeated phase of transition take place from liquid to vapor and vapor to liquid again and again. Okay, it is not one time transaction, it is a multiple transaction as long as your air conditioner is working. And based on that, in air conditioner, you might be aware of 4 components. Your heat exchanger, whether it is a condensing heat exchanger, whether it is a evaporating heat exchanger, or whether it is an expansion device. Apart from that, unless and until, apart from the compressor also, another than this 4 component, refrigerant becomes a most important part in air conditioning. In any refrigeration effect, for taking the refrigeration effect, whether it is for low temperature, whether it is for a positive temperature. So this refrigerant, without this refrigerant, we won't be able to give you cooling properly. Though there are some natural refrigerant also available and some synthetic refrigerant also available. So first I'll take you about the introduction. So this was my introduction. Apart from that, if you go through the history of air conditioning or history of refrigerant, so it is a more than 100-year-old technology where it has been used. Earlier, it was used CF, CFC refrigerant. Gradually, we moved to HFC refrigerant, and then now we have moved to HF refrigerant. So there are different types of refrigerant available in the market. So as on date, we are using, initially we started in earlier after World War II, the refrigeration was used was CFC, that is chlorofluorocarbon refrigerant. And this chlorofluorocarbon refrigerant was very good refrigerant in the market, but only problem was whether it is a CFC refrigerant or R32 refrigerant, hydrochloro. The chlorine was there, and during that period, today we are talking about ozone layer. Today we are talking about global warming. So earlier after World War II, this chlorofluoro refrigerant was much used. Okay, so CFC refrigerant has almost up till 90s, or you can say up till 80s. Okay, R11, R12 refrigerant were very much popular. R11, R12 refrigerant. Gradually, we came with R22 to remove R11 and R12. So after that, R22 was introduced, and in 90s, to replace R22, we have come up with the new refrigerant that is ozone friendly, that is your 410A refrigerant. So that refrigerant started. So that is, this refrigeration history is decades old technology. And when we are coming up with new refrigerant, any refrigerant, whether it is CFC, HFC, so some USP has to be taken care. Okay, so because we have to give this environment or human being that comfort, because these refrigerants in very, when heat is quite high at around 50 degree or at 55 degrees centigrade temperature, this refrigerant will give you proper cooling at that time. It is the only survival for us, for any human being. And when we come out with the refrigerant, we should, earlier nobody was aware of everybody was aware about the chlorine, but nobody has thought that it is going to impact on our ozone. Okay, so at that time we felt that this technology or this refrigerant was much better, because it was giving a synthetic refrigerant. Being a synthetic refrigerant, it was giving a very proper cooling impact. And it is a part of a thermodynamic, because when we are coming up with any refrigerant, we should think about its operating temperature also. And when we talk about this operating temperature, or when we are coming up with some new refrigerant, it is always, it is not like that anybody will come out with any refrigerant. That is a very vast investment, and apart from that, very research is there, because we have to think about the environment also. We have to think about the global implementation also. So gradually, if you talk about the principle of refrigerant, so there are the primary working fluid. So refrigerant absorb the heat at low temperature and low pressure and release at higher temperature and pressure. So most of the refrigerant goes in this phase manner only. Okay, whether it is a evaporation or whether it is a condensation, where heat transfer take place, because heat transfer take place in evaporation or condensation. These are the two heat exchanger. Apart from that, compressor role is only to compress the refrigerant and release the refrigerant, and expansion is being used to change the phase. Okay, so that was these four functions relation. When we talk about this refrigerant, we talk about primary refrigerant and secondary refrigerant. So because in system today we have got DX system also, direct expansion, and we have got indirect expansion. What is direct expansion? Where heat transfer take place from the surrounding, and where the in secondary where we heat transfer take place, the refrigerant and apart with the water system. Okay, so here water is also we are taking as a, because water is considered to be uh, one of the best friendly, ozone friendly refrigerant. It is not a refrigerant, but yes, with the help of refrigerant we can supply the chilled water supply. So today world we are using a two types of air conditioning. One is DX, direct expansion, where refrigerant is playing its role, whereas indirect, where the refrigerant is also taking paid role. Apart from that, the water supply, chilled water supply, is being transferred from one place to another to cool the my region. Apart from that, we will talk about the refrigerant types and characteristics. So terminology, R stands always stand for refrigerant. Example, if it is R22, if it is R410, so like that refrigerant. And initially it started with chlorofluorocarbon. When we talk about R11, R12, where chlorine molecules were more in compared to R22. Gradually it has replaced with HCFC refrigerant, hydrochlorofluorocarbon. Just for example, it is R22. And still it contains the chlorine, but compared to R11 and R12, their molecules content were less. Then in 90s, we have come with HFC refrigerant. It is a hydrofluorocarbon. By the time people started realizing, scientists have already started realizing that yes, suddenly this ozone depletion has taken place. So we have no choice. We have to come with some hydrofluorocarbon like 134A or 410, like that R32. There are multiple refrigerant. Today, some refrigerants are propane refrigerant is also available, natural refrigerant, and butane is also available. So gradually, this terminology started from here. Now, characteristic of the refrigerant. So that means some are natural refrigerant. So natural refrigerant, here we can take about carbon dioxide also, though its pressure is quite high, but still we can use it. Apart from that, ammonia, apart from that, water, apart from that, propane. These are the natural refrigerant where their ozone depletion and global warming is comparatively less than 5. Okay, less than 5. It is near to 0. And if we talk about fluorocarbon refrigerant, it is R22, R11, 410, R32, 123, 14, 407, R12. They are used widely, but because of their widely use, it has impacted our ozone layer also. It has depleted the ozone layer. So in our next slide, we will talk about the ozone depletion also and global warming also. Before that, I'll show you multiple refrigerant. So here, first letter R stand for refrigerant. Apart from that, if it is a methane series, it starts with 0. If it is a ethane series, it starts from 1. It is a propane series. If it is 290, if it is a 290, that is, it is a propane series. Okay, so like that, the refrigerant nomenclature is there. This is the nomenclature of a refrigerant. Apart from that, there are geotropes, azotropes, okay, organic compounds, inorganic compounds. So there are some natural and synthetic refrigerant in this particular nomenclature. Apart from that, if we talk about composition, so then R22, it is a chlorofluoromethane. Then we talk about 410A, then it is a mixture of two refrigerant, R32 and R125. So that means you can realize that R32 has come in 90s, but somehow it could not be used. Now we have started from 2012 onwards, we started using R32 refrigerant. Earlier we could have started refrigerant in 90s also. because 410 was available in 90s, equipment has come to replace the R22, and R22 in 2020 it has been banned globally. It is banned, neither we can import or export R22 refrigerant product, but still in India, because it is a developing nation, so we can still use up to 2030. Okay, by 2030 it will be. And if we are using, and most of the company has already started shifted their product on either on 410 or in R32. Earlier they were using R22 refrigerant, so most of the company has shifted, and even Daikin has also shifted into almost all its product on 410 and R32. As far as R32 is compared, there it is a single component gas as compared to R22. R22 was also a single refrigerant, but 410 is a mixture of two refrigerant. Apart from R32, it is a single gas refrigerant. So composition of this, whether when it is we talk about R11 or 12, it is a single component. Earlier it was largely used. Ozone depletion was comparatively more, and non-flammable gas. But gradually we moved to HFC refrigerant. Um, it was single component gas responsible for ozone depletion, and it is also non-flammable. But when we came with 410A, it is a mixture of two refrigerant, R125 and R32, and it is a ozone friendly. And today most of the refrigerants are ozone friendly refrigerant available in the market. But now from 2012 in India we started using R32 refrigerant, because Daikin has introduced their product in R32 in India. So it is a single component gas. It is very easy to charge the refrigerant, and it is slightly flammable. It comes into A2 class. A2 class. There are different types of classes for flammability, on flammability. So it comes in slightly flammable in compared to, if you talk about propane. Propane is more highly flammable. It comes into A3 class. Okay, so there are different class globally mentioned. So it is slightly flammable, but still it is a ozone friendly refrigerant, and global warming is also quite less in compared to 410 or R22. Now I'll take you to some critical environment issues. So today we are facing two critical environment issues. One is ozone depletion, another is global warming, that is earth average temperature is rising. So what is this? So we have to understand what was the ozone depletion, and gradually, and today hopefully by another 20-30 years, ozone depletion will be recovered. We are at recovering mode in ozone depletion. But yes, global warming, day by day it is becoming a worst. Carbon dioxide release is becoming worst day by day, and that is the challenge today, that how we can, that emissions, CO2 emission we can reduce. So what is this process? So here in this mechanism you can see your chlorine used to react with the ozone layer, and when this ozone layer oxygen, there was oxygen's component was available. Based on that, this, when ultraviolet rays, when sunlight comes, this was reacting, the chlorine was reacting, because chlorine is very light refrigerant, and it takes very less time to reach at ozone layer. So it has started depleting our ozone layer, and gradually now we have come, and it is impacted that related to the skin disease, related to eyes. So suddenly scientists thought what has happened globally. So based on that, they have come out that yes, ozone, our sunlight rays are coming directly, almost directly at a certain temperature. So that temperature we are unable to resist our human bodies. Okay, so based on that, they have introduced some HFC refrigerant so that we can this increase of harmful ultraviolet rays can be reduced. Okay, so that was the reason where we have come out with the uh, ozone depletion. Then again the global warming. So today global warming, greenhouse carbon dioxide is increasing day by day. So God has given us one ozone layer. So that was protecting us from our ultraviolet or direct sunlight hit to the earth. But mm, because of global warming, what we have done, like whatever heat sunlight rays used to come, it used to emit back to the atmosphere. But again, what we have done, we have created another layer that we call it as a greenhouse, okay, or we can say the global warming. So below the your stratospheres, we have created another layer, and that was a man-made layer. And because of that, the earth temperature is keep on increasing. And because of that also, you must have realized that day by day, uncertain of the weather condition has taken place. Okay, our weather pattern is also changing gradually, and it is impacting. So just to protect this layer, we have to introduce a new refrigerant. Based on that, uh, we can protect our stratosphere's ozone layer for depleting. Okay, because of that ozone depletion, how it is taking place? It takes place that CFC release, and it ozone layer, CFCs rise into a ozone layer, and ultraviolet from the sun, the ultraviolet rays used to hit that oxygen, and chlorine used to react, and because of this compound, this ozone depletion was taking place. And because of that, uh, your multiple cancers, disease, skin disease was taking place. So the health environment concern was there. Breakdown of ozone layer include the increase in the skin cancers, okay, human immune systems, increase in cat eyes disease was there. So that was the basic reason, was not only for human being, even for our underwater organs also. Okay, so everywhere it was, and not only in India, it is entirely, it was applicable to the global. So that was the reason behind it. The we have to come out with a new refrigerant to protect our ozone layer. So this was the, because of this greenhouse effect, or because of this carbon dioxide, heat was transferred. So that means initially God has given us one layer, and another layer we have made. It is a man-made layer because of deforestation, okay, emission of the CFCs or industries, fuels, okay, vehicles emissions. So like that, human activities day by day was increasing, and that was also necessary, but on the cost of, for damaging the your GWP, it was trapping the heat, and because of this, it was impacting, and because of that, you have must have seen that even your breathing problem also take place. Multiple human beings are facing problems because of greenhouse effects or carbon dioxide effect. Okay, so day by day, it is also been considered. So now this activity has to be taken care, and because of this, the new refrigerant was introduced. So, and apart from that, impact of global warming. So almost our 70% of icebergs are being located in Antarctica or in some northern region, apart from globally, and gradually that are, because of this, ice is getting melted, glaciers are melting, and because of that, there is a rise in the water. level. And it is, we are not saying, this is a WHO report that he almost, there are 800 million people. Total population of entire world is almost 800 crores. Okay, na? So that means 800 million people. Out of that, 11% of the world population within 30 years, it will be under the water. So that means our survival rate will be, is not possible when water is seepage to the our cities, okay, or at our villages. So that is, and it is not only globally, there are also possibility that multiple countries, their beautiful islands will be vanished from that particular, because of this impact of global warming. So it is estimated that by 2050, some part of, even in India also, we are going to western part of India or southern part of India, some part will be under the water, nearby villages which are being located at near sea level. Okay, so this is the condition. So that's why we have come out with the, we can now, already this condition has been raised. Now we can delay this, we can delay, as long as we can delay, that is much better for us. Okay, otherwise in another 50 years, hopefully multiple countries which are being located in the islands will be vanished. Okay, only we can see in the maps only, we won't be able to locate it in the, we can locate it in the map, but physically it is existence won't be there. So that is the condition and impact of a global warming. And gradually you must have seen it is impacting us also. Weather condition is also getting changed. So what is the way? So now, so something, some way has to be taken out. So these are the protocols, Montreal protocols and Kyoto protocols. These protocols are very famous protocol where maximum country has contributed their participation. And Montreal protocol is for ozone layer and Kyoto protocol is for CO2 emissions. So where maximum country has participated and they have agreed to start reducing, they started implementing some policies so that they can control the this global warming, because now global warming is more, initially it is now to become a headache for us, so that we can give some good impact to the environment. Okay, so now, and after that, because of previous slide, now we have come out with the phase out management also. So phase out management, so developed nations has been asked to chlorine related product to be banned, and it is already banned. And developing nation like India, it is based on that we can make, or it can make be available this R22 refrigerant till 2030. Production will stop at 2030, it won't be available. So that is, and Daikin has already switched before that, in 2012 we have switched over to R32 refrigerant. So that is also a part of a phase out management. So now you will see some comparison of some refrigerant. So here you can see 407C is there, 410A is there, R32 is there. So here you can see the condensing pressure also. It is in megapascal, okay, and R22. So initially we have made branch as a standard branch R22, because R22 was performing well, but because of its ozone depletion, we have to stop this product also, R22 refrigerant, though its global warming was 1810. And if we talk about 410A, its global warming is 2090, much higher than R22. But why we have stopped R22? It is because of chlorine. Because of chlorine, it was containing the chlorine. And after that, we have introduced the R32 refrigerant. It is also a single refrigerant as compared to R22. Its global warming is 675. Okay, it is 675. As per this chart, there are some HFC refrigerant and non-HFC refrigerant. Non-HFC refrigerant means it is a all natural refrigerant. So natural refrigerant are less than 3. But whereas if you talk about HFC, it is having a some global warming impact. Even 675 is in higher side. So today, again, multiple research is going on to come down with this new refrigerant, so that one day 410 will also get replaced, or even R32 will get replaced within a span of a maybe within a span of 10 years. So we will find, or they have to modify their global warming. Okay, how to modify? They can the properties, if suppose we are giving a suppose let's say 1 kg of the refrigerant amount is there in the system. So somehow we have to make our uh, heat exchanger and compressor, so that minimum to minimum refrigerant is being used. So that suppose at present Daikin is using for 1 TR product as a 600 gram of refrigerant. So how we can, if you talk about to reduce this GWP, so we have to reduce the amount of the refrigerant. We can come down with 50 grams or 100 grams. The moment we reduce that amount, keeping a your refrigerant effect intact, so without affecting that refrigerant effect, if we can reduce this GWP by reducing the amount of the refrigerant, so it will be, we can say that yes, we have modified the some amount of. So now you may get in near future equivalent to R32, you may get 454B refrigerant, which is as equivalent to global warming is less than 675. And if we compare with R1234 and HFO, right now research is going on. Based on that, in coming years, we can find that HFO refrigerant will also be available in the market. And but right now research is going on, so we cannot put some figure there. So it may be already Daikin has worked with HFO for refrigerant, related refrigerant, and we come with some low temperature product like refrigeration diffusers, like a diffusers. Okay, so but apart from that, again you can raise a thing that when we are using a 717 or 290, so 717 is ammonia. Yes, ammonia is so natural refrigerants are good as far as global warming is concerned, or ozone friendly, but toxicity is the major concern for that, because natural refrigerant has some toxicity, and because of that we are unable to use very vastly. So gradually, again research is going on natural refrigerant. So we cannot deny in near future you may find that natural refrigerant will also be used, and like butane or propane is being used for some systems like a low temperature system for diffusers gradually, because the amount of refrigerant, though it is highly flammable, because the amount of refrigerant is 100 grams or less than 200 grams. So like that, we have to come out with some solution. So in near future, we are thinking that some of the natural refrigerant will also be started using in the our air conditioning product, because today air conditioning and even refrigeration products are very widely used. Gradually they are increasing their um, product sales are increasing day by day. Now here I'd like to take you the global warming of some of the refrigerants. So if we talk about R11 or R12, their ozone depletion was 1, and R11, R12, here you can see that is global warming is 4750 or 10900. And if we compare, even if we compare with 410 and R22, presently it is 675 R22 for R32, sorry, R32. So R32 right now it is a very widely used and it is a very good refrigerant in compared to as a single component, as compared to our ozone depletion, as compared to our global warming. So right now no other refrigerant apart from the synthetic refrigerant, or apart from, you can say, in your natural refrigerant, because natural refrigerant definitely has a low GWP, but whereas synthetic refrigerant is having a very high. And right now R32 is at 675, and again we are claiming it that we have modified this 675 also. So again in next slide we will take you to modification of GWP, whereas you can see that GWP uh, and modify version of GWP. So we are claiming at 472. So if it is a 472, that means R32, if we widely start using R32, it can reduce the emission up to 75%. So if we could have started using R32 in early 90s, so by that time the impact of this global warming would have been very less as what we are facing today, because it has become a challenge for us. So as per this, we can go through this internal government panels climate change reports. So multiple reports are generated every quarterly, every month also. It is being directed by WHO. So where we can go through that, what weather patterns are changing, what climate change are being taken, is been happening. So that reports are generated, and every country has to create this report and submit to the GWP. So if we start using R32 refrigerant, so that means your, in compared to 410 or R22, so that means it is a 30% less refrigerant charge. Okay, and you get some saving in 5% saving in electricity also, because your refrigerant effect is more quickly, this better performance, and even at very high temperature. If you see uh, graph by R22 410, so R32 at very high temperature, even at very high ambient, let's say at around 50 degrees centigrade ambient temperature, the performance, the derating of that product is comparatively very less in compared to 410 or R22. As it is a single component refrigerant, so it is much easier for our engineers or our field engineers or our technicians to charge the refrigerant. But every time whatever refrigerant you are charging, that charge of the refrigerant you should be by weight. It is not by the pressure or by the ambient temperature. So if you charge the refrigerant by weight, it will be much better and it will give you the performance. Otherwise, when your temperature will keep on rising, suppose we have charged the refrigerant at 40 degree ambient temperature, and suddenly the temperature after 1 month it goes at 46 degree. So gradually your pressure will also increase, and when pressure will increase, so your system will either derate or it will it will work on high pressure. So that we have to understand. So whenever we are charging the any refrigerant, it has to be charged by weight, and the amount whatever the manufacturer has mentioned, that 600 gram has to be charged for certain length of the pipe. So that much amount of refrigerant has to be charged, and if you are increasing the length, then company is saying the, for smaller product we are saying it depends on the product to product. We are saying if certain amount of refrigerant charge has to be carried out, then 20 grams per meter has to be charged. So this is what we are saying. But company to company, manufacturer to manufacturer, it is different. As we are increasing the length of the our tubing copper pipe, so we have to increase the some amount of refrigerant. Otherwise, the impact of it will, it won't perform what you should get the performance. So because of that, low modified GWP, so 472. So we will reduce the some amount of refrigerant. That means today if we are charging 600, tomorrow we might charge 550 grams of the refrigerant. So when we are reducing the amount of that charging volume, so based on that, and because, and it is all design part, when we are charging less amount, so everything, the our both heat exchanger has to be taken care also. Based on that, straight away we cannot go with like that some amount of refrigerant. It has to be, it is a design part, so that our R&D team will decide what type of heat exchanger has to be used when we are reducing the amount of a refrigerant. Okay, so as per R32, so we are giving a superior cooling impact and even much better performance in compared to R22 or 410 refrigerant. Now, all this was about the refrigerant. Now we will talk about the properties of the refrigerant. Okay, so this, it is a highly pressurized. Today, if we are using a 410 refrigerant or if we are using a R32 refrigerant, it is a very highly pressurized refrigerant. Okay, and we have to take care of the safety of that particular, when you are releasing or when you are charging the refrigerant, we should have some safety valves, we should have some pressure regulators, so that based on that we can prevent that any hazards. Okay, even handling the vessels, we should keep that refrigerant cylinder at a proper place, so that unexpected accident doesn't take place. Or we should store that cylinder at a certain temperature, around something at a less than 40-degree temperature or around 40-degree temperature, so that suddenly the expansion of the refrigerant, because when it is in the cylinder, gradually if temperature keeps on increasing, it refrigerant temperature, if your temperature is increasing, ambient temperature, your cylinder temperature is also, pressure is also increasing, because temperature and pressures are related. Okay, and you must have heard that multiple accidents also. Sometime you must have heard that while traveling with refrigerant cylinder, suddenly it has burst. That is because of you have filled up that cylinder, and apart from that, when you're moving through by any vehicle, so the refrigerant is, what do you call, refrigerant is when it is highly pressurized gas, the refrigerant keeps on create a high pressure when it is moving in the cylinder itself, because it is not finding any escape space to escape it. So when the pressure will keeps on increasing, already refrigerant pressure is quite high, and apart from that we are giving an additional jerk, so that what will happen, suddenly the cylinder will burst, and when cylinder will burst, so casualty will also take place. So it is very harmful, and we have to take care of these cylinders also. So cylinder, we have to have a regulators before we charge, we should have a safety valves, and based on that only, and we have to keep old cylinders when, and we should, whenever we are charging the cylinder, we should identify R22 cylinder differently, R32 cylinder differently, and R410, because refrigerant have a different, refrigerant has a different pressure, and based on that, though R32 and R410 pressure is same, but still it is a combination of two refrigerant. So again, there is a pressurization will take place when your temperature is increasing. So we should identify the temperature, we should identify the cylinders color coding, and we should keep it in a proper way. And whenever we are using cylinders, or whenever we are charging the new refrigerant, initially we should vacuumize that particular cylinder, and after that we should charge the uh, new refrigerant in cylinder. Okay, while refilling, when we are refilling the cylinder, so based on that, the refilling of refrigerant must be taken care, and we should keep on gradually, we should keep on checking the cylinders, or we should use the cylinder which have got a safety walls. Okay, there are cylinders available in the market with the safety walls also, so we should buy that cylinders also, so that, and it is not recycled that once we have used R32, then we will use it for 410, or we just buy 3 cylinders and gradually you use it for the refrigerant. Anyhow, R22 will be within a span of, and maximum manufacturer has already stopped R22 equipment. So now only R32 and 410 refrigerant is available in the market. But when we are talk about the propane or butane, so that also, and even if we are using a cane, so today we are using cane for, even for brazing also we are using a canes, small canes are there. So we should buy a good manufacturers, that small cylinders, otherwise again hazard can take place while doing your brazing also, because when you are doing a brazing with that particular smaller cane also, that temperature is also around 200 to 300 degree when you are doing any brazing. So it is again, it will give you a some technician will have a some problem in that. For, so we should have a proper visibility, based on that the color coding, so that we can keep the cylinder properly. When we talk about service tools, so we should have a recoveries, whether we 410, when we talk about 410, so it is a combination of two refrigerant, or even if we talk about single refrigerant, so recovery cylinder should be there, recovery machine should be there, we should start using a recovery equipment. So today awareness of recovery the refrigerant is very less, so we should start, though it might be a very expensive product for buying a recovery equipment, but we should start using a recovery system, so that we can collect that refrigerant in one cylinder, and then we can either we can dispose of, or if you want to, if you feel that that particular refrigerant is proper, we can reuse it. But from my side I'll advise that key, once you're recovering the refrigerant, even with a good equipment also, so please do not charge it, because once it comes out, it won't give you the same property what refrigerant has got, or what. So recovery machine should be used. Manifold gauge, even manifold gauge you should, R22, R32 and 410 you can use manifold gauge, but as far as charging pipe is there, charging pipe should be different for R22, even for R32, even for 410. So today most of the technicians, they are using same charging pipe, and their charging pipe is not proper. If we carry out the inspection, you will find that most of the charging pipes are cracked, and again it gives you, when we are recovering the refrigerant, or when we are pump downing the system, at that time there is very likely the chances that air will enter there, because when you are doing pump down the system, that means you are creating a vacuum in the system. When vacuum is been done and you are recovering at a positive condition, so immediately it will go into that atmosphere air will enter into the system, and it will give you problems, for even compressor will get damaged, or even compressor can burst. Okay, that is the reason where we have to notice that our tools should be proper, especially charging pipe, and especially we should have a charging wall, so that amount of refrigerant, less amount of refrigerant is being leaked out from the system. Apart from that, weighing scale should be there. So it is a proper weighing scale. So we should charge the refrigerant in a proper way. Apart from that, vacuum pump is required. So there are some refrigerant, and because R32 and 410 is required some manifold gauge, at least we should have R22, and for our charging pipe should be different, so that it should never, because if you talk about R22, it is a mineral oil system, and when we talk about R32 and 410, it is a synthetic. So the oil grading is different, viscosity is different. So based on that, hazard can take place. So we should be very careful when we are buying we are charging the refrigerant, or when we are recovering the system. So that means here you can see that R32's pressure is almost 1.6 times higher than R22. And grading of the oil is different for R32 and for R22, even for 410. Though the refrigerant oil is almost, it is a mixture of refrigerant R32, but again, the viscosity of that particular component is different. So that means again impurities will take place, and we should, whenever we are charging, we should charge 410 with 410 tools, R32 with the R32. So we should have this awareness, so that uh, any hazard won't take place, and we will give the performance as good as what new manufacturer has supplied at your place. So here you can see we can share some manifold gauge, okay, 412 R32, but where we are talking about R22, it should be different, okay. And we should start using a torque range, torque range, and when we are carrying out the flaring, so everybody is carrying out the flaring and tightening the flare nut with adjustable range. Okay, you can adjust the adjustable range, but it is better that you start using a torque range. So torque range will, it is a torque is been created as per that piping design. So based on that, your flare won't get damaged, and refrigerant leakage will be very less. Okay. So that even we can use leak detector also. So leak detector is also another tool where some any refrigerant which has been leaked in the system itself, so we can deduct immediately. So there are some tools which we should start using it, and recovery machine and recovery cylinder should be, we should start using it. Apart from that, vacuum. So under this caution is there, never under any circumstance use cylinder with a faulty pressure. We should use the cylinder with a relief valve, so that any structural problems will be there in the cylinder, it should be helped out. Apart from that, the working air conditioning field technician should understand the general safety concerning before coming into contact with the refrigerant. We should know the what it can, if directly it comes in contact with the refrigerant, what is going to harm them. Okay, so refrigerant hazard, high pressure has cylinder burst. So here you can say even this personal injury, the frost bite, it is a very common thing which technicians are not aware, and therefore we are saying that they should use a charging wall, so that directly it won't hit on their body or in their hands. So here you can see the some hazard of a cylinder burst, because its cylinder was completely filled, almost 100% with refrigerant. Apart from it has been kept in the open air with high ambient temperature. So there is a possibility, even we are throwing the cylinders, we are rolling the cylinders, it is a, it has to be not being used. So if we are using like that, so there is a chances of cylinder burst also. Apart from that, here you can see that your if you are using, you should start using a gloves. And even we are not using gloves, this without gloves also you have seen that the frost bite is there. So that means it is as good as your, it's a burning of with fire. Okay, and within a second you will feel that your skin has been moved from that your particular face or your, and it becomes a very dangerous when it come directly hit, because the boiling temperature of these refrigerants is in minus. Okay, that is minus 51 degree, minus 48 degree, minus 41 degree. So we should be very, and when we are charging the refrigerant, we are sitting at around 40 degree or 45 degree temperature. Okay, so we should think that when we are charging the refrigerant, the proper tools to be taken care. And repeatedly, I'm saying that charging walls. So charging walls are available so that you can initially, before you are putting a your manifold gauge, you can put charging wall, and after putting a charging wall, you can rotate it clockwise or anti-clockwise. You can open it or you can close it so that the very less amount of refrigerant can escape or can hit your body. Okay, so we should take care of this. So always wear some protections while working. So basically when we are working on field, we should have some goggles. Okay, so we should have some gloves, so that in this condition we can, at least we can save our skin, we can save our body. It won't be very harmful. Or even if we inhale this, so we will, if we inhale this particular refrigerant, so it is going to impact, it can be a dangerous for our health also. Okay, so while recycling also, that is pump down system, we should take care of our tools. And if we have a proper tools, so we can carry out the pump down also personally. Otherwise, while doing the pump down, it will become a, because outside ambient will enter into your closed system, because it is a vacuum, and everything when it is entering the positive temperature, that means it is a moisture is also there, and suddenly then moisture dust particle will enter in the system. The compressor cannot compress, and when it is will try to compress, it will create a high pressure or high temperature. And when high pressure or high temperature is being generated at in compressor, immediately there will be a blast in the compressor, and you will have a fire also. Apart from that, at the time of installation also, we are uh, carrying out the electrical supply at indoor unit. So maximum companies are, even international companies, all companies are asking for outdoor your electrical supply. But somehow we are running our system at indoor unit charging, because indoor immediately, because indoor is total plastic body, whereas in compared to outdoor, so your, even if your there fire take place at outdoor unit, there is a multiple chances that you will survive. But when it takes a blast take place inside your room, so casualty will take place. Immediately it will take, immediately fire will take, it won't give you any seconds also to understand what to do. So skin and eye protection should be carried out. Never handle liquid refrigerant without a proper protection equipment. Never fill the refrigerant 100%. The refrigerant should be filled 80% of its capacity. So here there are some risks and safety precautions. So refrigerant should never come into contact with the eyes or some. So again, it will be a serious injury or blindness could take place, result will take place. Apart from that, if first aid, we should at least wherever we work in a fresh air environment, or we should have a ventilation, proper ventilation should be there, so that if proper ventilation is there, so that even if any hazard take place, so it won't going to affect you immediately. You will have a time to rethink, and you can contact some first aid team so that they can come and give you the assistant. Okay, because these gases are poisonous, and when we talk about whether it is a natural or whether it is a synthetic, somehow it is a toxicity is there. So when toxicity is there, so it is going to harmful us. Okay, here you can see some cylinder, how to secure the cylinder in upright position. So maximum cases we find that cylinders we are keeping lying down. It should kept in upright direction also, and it should be less than 50. Refrigerant temperature should be around 50 degree or less than 50 degree. Okay, never we should throw the cylinders. Okay, so suddenly if you are throwing the cylinder, the pressure will increase, and when pressure will increase again, it will burst the cylinder itself also. Okay, so or never temper the safety devices also. So this again, it is in continuation of this handling of refrigeration. So we should have a open cylinder valve slowly. We should never use, so we should open immediately. So we should have a proper walls so that it can rotate gradually, so that immediately the refrigerant is not released. Even your nitrogen is been not released immediately, because nitrogen is also again, it is a dry nitrogen is also very harmful, and maximum cases while doing at the installation, when they are using a nitrogen cylinder, they are this, it happens that they gives more pressure, because they don't have a proper key or they don't have proper regulators, safety valves. Based on that, sudden increase of a pressure, because in nitrogen cylinder the pressure is, even if we talk about a smaller cylinder also, it will have a 1500 psig pressure, or even if it is a bigger size, then it has something around more than 2000 psi pressure. It is good enough to throw out you and even your equipment from that particular site. So we should use proper cylinder, proper manufactured cylinders. Even we should use a proper gauges, so that any unwanted incident doesn't take place. So safety precaution, what if when executing the repair in indoor, make sure that there is always force fan ventilation is there. So we should, when repairing at outdoor, force ventilation should be surrounding the walls. Okay, accident, ensure that enough ventilation should be there, oxygen should be enough, and even the oxygen or air must be avoided at the time of inside any refrigerant circuit. So if it is oxygen, because our compressor cannot compress air or oxygen, again it will create a pressure, and possibility accident will take place. And it is advisable that unit has been pumped down. When there is any doubt, if you have any doubt, first you run the system for at least for 5 minutes, 10 minutes, and after that you start the pump down immediately. First you should check the proper whether my system is having a proper pressure or not. If my system doesn't have a proper pressure, it means we should understand that it definitely it is a under pressure system, and possibility of air must have entered in the system, and it is going to impact us. Okay, so that, and when we are doing pump down and suddenly accident will take place, we won't be able to understand what has happened, but actually the air have gone inside, or it was the air was ultimately was inside. Okay, so because when you're doing the pump down, that means your discharge port is closed, your discharge valve is closed. So that means whenever compressor is unable to release the refrigerant, creating a pressure, and because of that high pressure, the temperature is also increased, and because of temperature increase, the failure or blast of the equipment take place. Even while flowing the refrigerant and nitrogen, we should also check what amount of, as per the manufacturer, we have manufacturer declares that at what design we have designed these heat exchangers. Based on that design pressure, and it is mentioned in the your product itself, whether it is indoor or outdoor, design pressure is been mentioned. So based on that design pressure, we should charge the amount of nitrogen. Okay, it should be less than the what they have recommended. So whether it is for outdoor, whether it is for a smaller unit, indoor unit, so design, based on the design pressure, we should charge the nitrogen when we are checking the leak, any leak. Okay, so that safety precaution we should carry out. Apart from that, uh, do not modify or any, uh, because if we are keeping a sufficient distance away from the fire, ignition can take place, burning the equipment and electricity heaters. So that means additional precaution should be carried out. So during vacuumation or charging, do not overfill the refrigerant system. So always be well aware of the material specification. So whatever refrigerant you are charging, whether it is 410, R22, R32, or any other 290, the specification should be, you should be aware of that specification. And all specifications are available in maximum case. You can call the manufacturer and they will give you, or even companies are mentioning everything in their catalogs also, at what design pressure it has been there, so that everything is been mentioned on product also, or even in the specification sheet also. Specification sheet means that catalog, and even if you can call and ask company, the company will definitely will help you in this, to give you the specification of the product. So at last we can say that the unit, the cylinder here I have mentioned that we should never charge your refrigerant at 100 degree, at 100%. It should be at around 80%. It should be less than 90%. Okay, so as you have seen here, gradually if you are moving from 85% to 95 and 100%, and even your ambient temperature is also where your temperature, your cylinder has been kept. So there is a possibility when your cylinder is at 100%, so blast, it will explode. And definitely when we are talking about a very high temperature, so again it is a very dangerous, and it can lead to a some casualty. So that we have to take care. So that's all from my side. So thank you for your participation.
Awesome. Mr. Singh, thank you so much for such a detailed presentation. I think everyone who's heard about it, this is like a good reference on refrigerant handling. Thank you very much for this. Thank you for taking time out and sharing this information. I'm sure everyone who's watched this or who's going to be watching this will definitely come back again and again to get some of those critical information. So thank you, Mr.
Thank
Singh.
you.
Thank you very much.
Thank you very much, sir.
Thank you so much.
From the land that celebrates innovation and breathes enterprise, comes the next chapter of India's HVAC and HR journey. 3 cities, 4 milestones, 1 vision. RATA Conclave, India's most powerful platform for HVAC and R entrepreneurs, thinkers and changemakers. And now in 2026, we converge in Ahmedabad, the growth capital of the West, where business meets purpose and sustainability meets scale, empowering HVAC and R business for sustainable growth. 1,000 plus delegates, 70 plus industry speakers, 80 plus partners, 3 power-packed forums, National MSME Awards, live networking and product showcases, a marketplace of ideas where innovation scales, connections deepen, and opportunities compound. Experience it all in the soul of Gujarat. Culture, cuisine, and celebration. Only in Ahmedabad. Join the movement for MSAMS to thrive, manufacturers to evolve, and the ecosystem to advance. Mark your calendars 25 and 26 September 2026.